Today we are going to learn about Introduction to C/CD for model deployment. We will explore C/CD concepts, how to set up and automate model testing, and deploy models using C/CD pipelines. Welcome to our session on C/CD for model deployment. Continuous integration and continuous deployment, often abbreviated as C/CD, are critical components in modern software development. They play a pivotal role in streamlining workflows by automating the integration of code changes from multiple contributors into a single project. In the context of model deployment, C/CD ensures that machine learning models are tested and deployed efficiently and reliably. Throughout this video, we will delve into the benefits of C/CD, explore how C/CD pipelines work, and discuss popular tools used in the industry.
In this section, we will explore the core concepts and benefits of C/CD. Continuous integration, or C, involves the automation of testing and integration of code changes into a shared repository. This helps in identifying code defects early, ensuring that the codebase remains in a deployable state. Continuous deployment, or CD, enables the automatic release of validated code changes to production. This reduces the manual effort, minimizes errors, and ensures quicker updates. The primary benefits of C/CD include improved scalability and reliability of deployments, reduced risk of errors, and faster time to market. By consistently integrating and deploying code, teams can focus on quality and innovation, ultimately delivering value to stakeholders more effectively. Version control is a fundamental practice in software development that is equally important for machine learning model deployment. It allows teams to track changes, collaborate efficiently, and maintain a history of modifications. Git is a widely used version control system, and platforms like GitHub and GitLab offer robust features for managing repositories. By setting up version control for ML models, teams can ensure that every change is documented, making it easier to revert to previous versions if necessary. It also facilitates collaboration by allowing multiple contributors to work on the same project without conflict. Best practices for version control include committing changes frequently, writing descriptive commit messages, and using branching strategies to manage different versions of the model. These practices ensure a smooth workflow and enhance coordination among team members. Testing is a critical component of the C/CD pipeline, ensuring that code changes do not introduce new errors. In the context of machine learning, testing involves validating model performance and accuracy. Automated testing frameworks such as PyTest and Unitas can be configured to run tests automatically whenever changes are detected in the codebase. Types of tests include unit tests, which verify individual components, and integration tests, which evaluate the interaction between components. Automation of these tests reduces the manual testing burden, increases efficiency, and ensures that models consistently meet quality standards. Continuous validation of models through automated testing helps in maintaining the integrity of the deployment pipeline and ensures that only reliable models are deployed to production.
Continuous integration tools such as Jenkins and Travis are essential for automating the build and test processes in a C/CD pipeline. These tools help streamline the integration of code changes and ensure that each change is validated before being merged into the main branch. Setting up a C pipeline involves configuring the tool to automate the build process, run tests, and provide feedback to developers. This includes setting up test environments that mimic production conditions and configuring notifications to alert team members of build status. By leveraging C tools, teams can maintain a high level of code quality, reduce integration issues, and enhance their overall development workflow. Deploying machine learning models using C/CD pipelines involves automating the release process to ensure that models are deployed efficiently and reliably. Deployment strategies such as rolling updates and canary releases allow teams to gradually release changes to production, minimizing the risk of disruptions. Automating deployment with continuous deployment tools ensures that validated models are automatically released to production environments. Managing production environments involves setting up infrastructure that supports scalability and monitoring deployed models to track performance and detect anomalies. By implementing these practices, organizations can enhance their deployment workflows, reduce downtime, and deliver high-quality models to users consistently. Integrating C/CD pipelines with cloud platforms offers numerous benefits, including scalability, resource optimization, and enhanced security. Cloud platforms such as Amazon Web Services, AWS, and Google Cloud Platform, GCP, provide services that support C/CD processes, allowing teams to automate their workflows more effectively. Setting up C/CD in the cloud involves configuring cloud-based tools to manage code repositories, build environments, and deployment processes. This facilitates seamless scaling of resources based on demand and ensures that infrastructure costs are optimized. Security considerations in the cloud include setting up access controls, encrypting data, and monitoring for unauthorized activities. By leveraging cloud platforms, organizations can enhance the efficiency and reliability of their C/CD pipelines, ultimately delivering high-quality solutions to their users.
Security is a critical aspect of C/CD pipelines, ensuring that the deployment process is protected from vulnerabilities and threats. Common security risks in C/CD include unauthorized access, code injection, and data breaches. Implementing security best practices involves setting up role-based access controls, encrypting sensitive data, and using secure pathways for data transmission. Tools for security automation, such as static analysis and vulnerability scanning tools, can be integrated into the C/CD pipeline to detect and mitigate security issues early in the development lifecycle. Continuous monitoring for threats ensures that any suspicious activities are identified and addressed promptly. By prioritizing security, organizations can safeguard their deployment pipelines and protect their software solutions from potential threats. In this section, we will explore a case study of a successful C/CD implementation in a machine learning project. The organization faced challenges such as slow deployment cycles, integration issues, and inconsistent model performance. By adopting C/CD practices, they were able to automate their build and deployment processes, reducing the time taken to release new models. The impact of this implementation was significant, leading to faster deployment cycles, improved model consistency, and enhanced collaboration among team members. Lessons learned from this case study include the importance of automating testing and deployment processes, using cloud platforms for scalability, and prioritizing security in the pipeline. Future improvements involve exploring advanced deployment strategies and integrating more sophisticated monitoring tools to enhance the C/CD workflow further.
In conclusion, C/CD practices are essential for modern software development and model deployment. They offer numerous benefits, including improved efficiency, reliability, and scalability of deployment workflows. By implementing C/CD, teams can streamline their processes, ensure consistent model performance, and deliver high-quality solutions to users. We have covered various aspects of C/CD, including setting up version control, automating testing and deployment, and integrating with cloud platforms. Security remains a top priority, and adopting best practices ensures a robust deployment pipeline. We encourage you to explore C/CD practices further and consider adopting them to enhance your model deployment processes.